All right, just some extra practice problems. So here I have a secant tangent combo. They're both even powers. So between my two options for my du, I know I want to make the secant squared my good du. So secant squared pulled off to the side, that's my good du. So du is secant squared of x. So I know that means that my u is tangent, because the derivative of tangent is secant squared. So that means that will be taken care of. That will be taken care of with du. So I need to rewrite secant squared in terms of tangents. So secant squared in terms of tangents is tangent squared plus 1. And carrying this along, and secant squared x. So take the step. It's really important that you have all x's, and then you use your u substitution with all u's. That's u to the fourth, because that's tangent to the fourth, and all of this gets taken out with the du. So let's multiply this, adding their exponents, and then taking the antiderivative. And putting the trig function back in. Plus c. All right. So looking at this one, I can see that there's odd powers on both of them. So for this, I want to take off a secant and a tangent. So I'm going to leave a secant squared and a tangent to the fourth. And I'm going to have them off to the side, my secant x and my tangent x dx. So that's my du. Okay, that's my du. So if du is secant tangent, u is secant. Excuse me. Okay, so let's see what's going to work. If u is secant, this will be taken care of. This will be my du, so I just need to rewrite tangent to the fourth. There's no identity with tangent to the fourth, so it's necessary to think of this as tangent squared x squared. Okay, so let's use our identity on tangent squared to get it in secant. That's what I need, right? So tangent squared will be secant squared x minus 1 squared. Make sure you get the identity right. So now I'm ready to put my u in. So I have u squared minus 1 squared, don't lose that, right, times du. So this has got to be multiplied out. So I get u to the fourth, this times 2, plus negative 1 squared, which is 1. So now I get to multiply it, adding the exponents. And finally, oops, sorry, that was kind of messy. So finally, adding 1 to the exponents. And putting the trig function back in. Secant to the fifth and 1/3 secant cubed x plus c. All right. Okay, I wanted to do this one because I wanted you to see that this could be done either way. Sometimes there's options, meaning you could choose the du, two different things. Okay, so let's look at this one. So I see that there's an even power on the secant, so I could choose to pull off a secant squared. Remember, that's always your first step. Find out what your du is going to be. So if my du is secant squared x, then my u will be tangent, because I know my derivative of tangent is secant squared. So if my u is tangent, that will be taken care of, right? Making u substitution work, that will be taken care of. So I would need to rewrite secant to the fourth. So you would have to think of this as secant squared squared. Oops, lost my x. Secant squared. Okay, so rewriting this, I would say that this is tangent squared x plus 1 inside the square. Tangent cubed, secant squared. Okay, so now we're ready for the u substitution. Using u as tangent. So I get u squared plus 1 squared. This is u cubed, and this is du. So I have to multiply this out. So I'll get u to the fourth plus 2u squared plus 1 times this u cubed. And again, I have to multiply out, adding the exponents. And then I would finally integrate. So let me come up here actually. So I would add 1 to the exponent, so 1/8, 2/6, 1/4, and then take the time to put the u of tangent back in, right? So 1/3 tangent, 1/4 tangent. Okay, so that's one answer. Okay, let's do it the other way. Meaning, if I take this problem and instead of making my du this, I said let's take and make secant to the fifth tangent squared and have a secant x tangent x off to the side, right? So secant to the sixth turned to secant to the fifth times secant, tangent cubed, tangent squared times tangent. So I'm letting my du equal secant x tangent x. So my u is secant, because the derivative of secant is secant tangent. So to make this u substitution work, that would be taken care of. This is my du, so I just need to rewrite tangent squares in terms of secants. So let's do that. So tangent squared is equal to secant squared x minus 1. Oops, sorry, kind of messy here. Tilting down. Okay, now I'm ready for my u substitution to work. So this is u to the fifth, u squared minus 1 du. So I'm going to multiply this out. So I'll get 1/8 u to the 8th, 1/6 u to the 6th. And now it's time to put my x's back in. So I have 1/8 secant of x to the 8th, 1/6 secant to the 6th. Okay, this answer is equivalent to this. They look wildly different, but that's okay. They are the same. And so I'll often put the same answer on, or put both answers on an answer sheet, and you don't have to change one to another. This one, I'm just making the point, you really, really are going to encounter this. I want you to get familiar enough to say, oh yes, I remember this is the integral.